Hello and welcome everyone. My name is Hannah Mason and I'm an associate editor at Composites World. I want to thank you for joining us today for this webinar titled The Future of Advanced Materials Technology, brought to you by Composites World and presented by CMS North America and Diversified Machine Systems. This webinar will be a roundtable discussion where our presenters will discuss anticipated technological advancements that will be key in setting the new standard of excellence for CNC machines. We have 4 presenters today. Our first presenter is Patrick Bollar, founder of Diversified Machine Systems. Patrick has 40 years of experience within the manufacturing industry as a machine designer and builder. He started at his family's CNC business, ultimately started his own shop, which has evolved into DMS, and that now supports a line of 3- and 5-axis machine tools in a variety of industries. Our second presenter is Mike Crosby, Chief Operating Officer and Director of Sales for CMS North America. Mike joined CMS in 1991 and has worked in several sales roles, working up to his current position. He worked with leading industry partners to help expand the Advanced Materials Division into automotive and other industries, and expanded his role to include COO in 2020. Our third presenter is Marty Sutton, who is CMS North America's premier metrology expert. Marty has been in the field of metrology and CNC technical maintenance for more than 25 years. Our fourth presenter is Armand Alexiev. He is the head of innovation department at DMS. Armand graduated from the University of Colorado at Colorado Springs with a BS in traditional physics. Since starting at DMS, he has steadily worked his way from the production floor up to his current role as head of innovation. So this discussion will last about 40 minutes, followed by question and answer. If you have a question, you can type it in at any time during the webinar in the Q&A field to the right of your screen. This webinar is being recorded and when complete will be made available to you via email from Composites World. Okay, guys, it's all yours. What technological advancements do you anticipate as the key to new standards of excellence for CNC machines?
Well, welcome everybody. Again, my name is Patrick Bollar. So my job currently right now is, as an OEM, is to react to industry change. And what it's telling me these days is that it really wants less input with more output. Now that's a tagline from Armand over here. I've kind of adopted it and kind of stealing it, saying it's my own. I'm continuously talking to CEOs, customers, production people, and our main topic has clearly been the labor force and what the government policies are doing to increase the cost of labor and employees is on everybody's mind, and that's typically about 40% of what I talk about when I'm talking to customers. And as a result of that, of the extra costs, the minimum wage, and everything you can think of on that, the basic result of that is that the cost of robots is going down. So automation and robots are getting cheaper every minute we make a change where employees cost more. So what does it really mean to have less input and more output? It's really, we have to start asking our questions as an OEM is, well, how can we make our machines do more? We need to do more, such as, can it do more than one operation? Can an operator run more than one machine? Can it unload itself? Can it check itself? Can I pick up an end effector out of a tool change and use it as a robot? There's many things it can do, and there's many more things it can do, and that's the fun part of my job, is inventing new ways to do that, and I'm sure Armand will tell you about some of those. But from a continuous improvement from an OEM, we're always talking about safer, smarter, better, faster. How can we have this produce more for less input? And the answer is yes to all that. Like I said, there's nothing we can't do. My favorite personal customers are the ones who task us all the time. How do we do this? This is my need. This is what's going to make me profitable, and we have to design a machine specific to that. Our companies, between our companies, that's the main difference is we're very flexible on what we can do for the customer, and when our greatest successes have been when we've actually seen a customer grow from what we do. So as a machine designer, there are many things to consider when you're actually designing a machine, and it's not just the little things; it's the big things too. So when we say that our machines are robot ready, for example, I'd say that any machine that's 8 years older is basically robot ready. We're talking about some M codes and some inputs to make sure the robot starts and know when it's finished. That's what robot ready really means. But when I talk about robot ready and what we're seeing the industry move to is let's physically change the force of the machine, because robots in general are not cheap. I mean, there are cheap ones. So can we make the machine use a cheaper robot or a more expensive robot or Cartesian robot, which is simply a material handling device instead of a robot? So what we've been doing as a designer, I've been designing machines, like I say, for 40 years, but I haven't had that thought process to where, okay, but is this machine truly robot ready? And again, I need to define what that means. It's not just the inputs. We're saying, can I use a small robot or a cheap robot to limit the stroke of it? Because we can buy a $400,000 robot to reach way over there and have to do everything over here. But can we make the machine deliver the part to a cutting tool and deliver it back to a robot? So maybe you're only using a $50,000 robot instead of a $400,000 robot. So once you put that into the design criteria when you're designing new machines, it does change it. And the benefits from that change, again, get multiplied. You don't even know it when you first start it. I was having a nice long talk with Marty over here today about dust collection. So it's a very simple thing to say that dust, if you have a smaller area, it's a lot easier to control dust than a large area. So what do the customers really need? What parts are they actually cutting? All those come into the design factor of that. So we are making, for example, I'm making this special machine right now for a guitar company. And the result of it is I can run this thing and load it and unload it automatically with a $50,000 robot instead of, this multi-$100,000 robot that's doing it. So I have a bunch of projects working like that, and it's been a fun change. I did that about 2 years ago. So generally, that's what our factor is. And what you're going to see in this meeting here is Mike's going to talk here in a minute. You can join in anytime you'd like, by the way.
Okay.
But you're going to hear from Marty and Armand about, what type of improvements we're actually doing and how we can help you. But again, the interaction with the customer is the funnest part of my job. Show me what you're doing. Show me what you're cutting. I'm going to give you a value engineered machine to produce your parts faster than better than you can think of. That's my personal goal when I'm talking to the customer. So all of these things that we're talking about, we can do, we've done, we're in process of doing it, and we're really waiting for more input from the customer base to tell us what they need next. So back to the safer, smarter, better, faster, it's really unlimited, and it's the joy of what I do. So for example, on the hybrid machines, they were talking about multifunctional machines. So does hybrid really mean an additive machine? No. Hybrid means it does more than one thing. So can we add one more thing to this machine? And what an example of that it would be is for the hybrid machines that we personally make, we're depositing metal, and then we have a machine tool next to it to actually machine the metal. So we can come up with a finished part right off of the thing. So that's 2 operations. I know Mike has sold machines, and I'm going to let him talk about something he recently sold when you talk about a hybrid system or a hybrid solution.
Well, thanks, Patrick. There's a lot of things when we talk about multi-functioning machines. Obviously, floor space is important for people. So the more that we can get done on one machine with maybe one operator, the better off we are. But some of the examples of things that we can do, we can have a water jet head along with a conventional cutting head. So I use water jets where I need to. We've got a customer that cuts stainless steel with the water jet that is integrated into another part that's composites, and they use conventional cutting for that. We can add ultrasonic to our conventional machines. So we can actually go pick up an ultrasonic head, cut whatever we have to with the ultrasonics, put that away, use it for other operations or to do some additional trimming on core. We have UHF, which is just a modular system. It's a fixture system so that it can automatically set itself up. So if your lot sizes are very small, and that's where things are going. It used to be that people had large lot sizes. Then all of a sudden, JIT or just in time came in. Well, it's still that way. People can't afford to do large parts, to inventory, to have all this stuff going on. So they need to make them just in time. That means lot sizes anywhere from or down to as low as 1. So with a universal holding fixture, we can actually change from part to part automatically, have the head come in there, machine it, they take it off, reset itself in a matter of minutes, and they keep going. There's no more loading, unloading these big tools that take a long time to align. We've also got additive manufacturing. So we can do additive on one machine and subtraction of that material on the same machine. Saves a tremendous amount of time. It's all this type of automation that makes the machines more useful. They become friendlier. They get the jobs done better, faster. We're not changing setups. I think that's where the future is. The machines themselves are getting better. They're getting better because of the speed of the equipment, the accuracy of the equipment, the software that we have, the technology we have for maintaining the machines to keep their accuracy correct. All of these things are what we're doing now and what we're improving on and continuing to improve on every single day. It's I don't know any other way to do this. Like Patrick has said, we actually follow what the customer asks. None of the things that we've come up with are just ideas that we thought, wow, this would be cool. Let's see if we can take this to market. It's because the customers have been telling us, we need this. We need more production out of our equipment. We need to get, not add to our staff, but we need to add equipment, get more output, be able to generate more customers. Quality parts. So all of this is part of the multifunctional machines. And that's where I see things going. I mean, we talk all the time internally about what customers are asking. And I'll call Patrick. I mean, Patrick's got, like I said, 40 years of doing this. So I get customers that ask, can we do this or how do we implement this? And Patrick's generally got the answer because he's already seen it. Might say 11 years ago we did something like that. We do the same thing with our engineering department. We're listening to the customers, and that's how the machines are improving and moving forward. It's because you guys out there have a need. You know what's generating your dollars, what's making your business grow. So as we continue to communicate and find out what those are, we continue to do the things, add the ultrasonic, add the additive, add the universal holding fixtures, add multiple heads. We also have customers that have, and we produce machines that will change heads. They might need a very high torque head, and we can do machining with that. We can go put that head away and get another one and put that up there for doing smaller work or where they have to get into tight spaces. So it's all in a machine being able to do multiple tasks. And then once they've completed those tasks, what Patrick was talking about on the robots, whether the robot reaches into the machine, whether we're presenting the parts to the robot, however we're doing it, to be able to have these robots pick up the parts, put them on the machine, take them off, stack them, any number of things that you can do. Picking up the end effector and moving the parts around from one side of the machine to the other. The ideas are limitless, but this is where it's going. And we're seeing more and more of that people want a machine that can do more tools, more capabilities with different heads. I want to have full flood. I don't need full flood all the time. Sometimes I need a misting system or an MQL system. So all those are things that I see us continuing to move forward with.
There's a case when I had a customer come to me. It's very common when I first talk to a customer, he has one part and he wants to know the best way to cut it, what's the right machine tool for him. He'll ask what cutters, all this stuff. But this particular customer came to me and said, I have a part set that I need to cut on your machine of 350 parts. And they want to know how many machines they're going to need to buy to do the part set in 8 hours. That's how it was presented to me, which was very unique for me. It took a long time to answer that question. It took me about a month to actually work all the details out on that. But at the end of that, obviously quick change fixturing and how fast we can fixture and change from job to job and from part to part was the critical component on that. And we actually took a study throughout our company of about 100 customers, and the average time that we got for a changeover on a part was a little over 30 minutes. I mean, some people had 2-hour changeover times. Some people really, about the lowest one we found was about 15 minutes. So we developed a quick change tooling system or fixturing system for this particular customer, and there was a barcode involved in it. So they literally could change a fixture out and cut apart. Now, this was interesting. It was on a pendulum processing machine. So it's cutting this part as you're changing out the part in the other cell, completely safe on the other side, so the machine never stops running. But in this case, before it could get over here, because it only took 10 seconds to change the fixture out, it was literally this and put it back on there. The barcode was built into the machine. So as soon as they put the fixture on there, the program was automatically loaded into the machine. They could put a part on there, which was probably another 5 seconds, but the cycle time on the other side was about 2 minutes. So we had plenty of time to switch the fixturing out in the middle of the run to get to the next part. But that's the type of things we can do to it if we know that's your application. You know, to retrofit out on a machine and a quick fixturing system, unfortunately, there is a cost associated to that. And if you don't start that way, and you've already spent, you don't know how many times I've gone into customers and you see these pallet racks of fixtures that are on the wall, and you're like, wow, what an investment they've made in that. And for them to have to touch that huge investment and start over again, it's a hard ask, let's put it that way. But is it the right ask? Yes, good for your long term. It's absolutely the right thing to do. But if it's hard. I feel for them when I look at it, but fixturing is the easiest and fastest way for you to start making more money on your machine, off of your machine. There's no doubt.
Yeah, we've got it down to 7 minutes now from changing on the UHF system, even on a small machine. 7 minutes to change from one fixture position to another, and then be loading parts and machining them.
You might want to elaborate on what a UHF.
Universal holding fixture.
So these are multiple pod system with CNC control pods that can
Actuators, yep.
Yeah, and they can hold on to contoured parts of all shapes.
All shapes, any shape, your engineered shape, so we can actually position this just like your engineered drawing. Again, 7 minutes. So if your lot size is 1, you're golden. You can be machining on one side and resetting up another system on the other. It's a big deal.
It's a big deal. What they don't talk about on that system a lot is there's the other advantage to it. Obviously, the cycle time to get it back in is when you're talking about a system like that, you're talking about typically large parts. These aren't typically little small parts. We're talking maybe a 5 foot by 20 foot long part. And what that means typically without this system is they have a 10,000 square foot building to hold the 20 fixtures that they have to do that. And the safety from the loading system, the safety of just the reliability of moving that heavy thing back on and off, the crane system you have to do, all typically goes away. So you can't just look at because those things are typically not a cheap system to do, especially on the big machines. But if you look at the whole picture of the footprint that you need, it's an amazing return on your money. But again, we're still talking about a lot of zeros to get that done.
Yeah, but you're also, the speed and the safety are big deals. But now then the machine is controlling all of this. You don't have an operator worried about operator error or transposing numbers. All of it's automatic. You call up the program and it's done. Another beauty of this type of thing, and this is just part of the multiple functions of a machine, but another big deal is, and I know none of you out there have ever had this problem, but I've heard stories about it. You have a run of 5 parts and they're off, and then you pull that fixture off, you put a new one on, and you've got to make another 5 parts. Well, one of the parts in the 5 got damaged. So now what do? All I have to do is interrupt what's going on, reset it to the program, make that one part, and keep going. So the amount of hours that you've saved in that is tremendous. So again, and then the safety of it, the barcoding, being able to identify the tools with chips that are in there that keeps you from making mistakes. It's all about, really a lot about safety, and footprint, floor space for maintaining and managing these tools. If you've got to do ultrasonic and regular cutting, you can do that. Again, water jets. It goes on and on. Anything that you can come up with, we probably have a combination already of that. And two is not, we talk about two, multifunction, but there's no reason you can't have more than two. You can have three, maybe even four, depending on the size of the machine and what you're doing. But even with this UHF type, we can get down to small parts. The large parts obviously is where it started, small parts. But again, where is the future going? It's going to machines that can do more than one thing. They can do them faster. They can do them more accurate. They can do them safer, take up less floor space. All of that is where we're heading. And we're heading that way with your help. So as you come up with questions, ideas, thoughts, I always encourage people to take a blank piece of paper and say, if I could have whatever I want, this is it. And let's see where we are, because we've got customers all over the world doing everything you can imagine. And likely something that you're going to come up with is something that we may have already done.
That brings up a good point too. From what I've seen, what's been happening is the status quo has been challenged.
Yep.
So what has traditionally been the way they milled ribs or stringers in aircraft or rockets are pretty new, so there's not really a status quo as far as rocketry goes. But aircraft has been stuck in a rut for a long time, and they used heavy metal cutting machines to now cut composite parts. They're using hard metal cutting machines that have a rapid of 300 inches a minute, and we can cut many of the materials in advanced materials and composites 4,000, 5,000, 6,000 inches a minute, and they can't even rapid that fast. So this is what you're talking about, starting with a blank piece of paper, and what both of our companies are working towards is developing machines that work in this realm of high-speed machining, where spindle speeds now are 18,000 RPM is slow. But we're looking at 40,000 RPM spindles that can run 10,000 hours. The technology in spindles and bearings and all that can make a reliable 40,000 RPM spindle. Where in years past, a 40,000 RPM spindle would last you 1,000 hours. Now you can get 10,000 hours out of the same spindle. I mean, they've been around a long time, but they were never really reliable to the point where it made much sense. But if you can spin at 40,000 RPM, you have a smaller chip load and you can feed faster and get the same surface finishes, the same result at much, much higher speeds. That's what our companies are heading towards. And composites have changed a lot of the materials. Applications where, like, for example, steel and concrete, now they're composites. And concrete doesn't really sound normal for this audience, but building facades, now architects are getting very, very creative in different shapes and buildings and architecture and things like that. They're not made out of concrete. They're made out of composites. And all these composites can be assembled with lightweight machinery instead of having to make forms in concrete that it's just, they were impossible at the time, even currently. So composites has a lot more to do with everyday life than just aerospace and rockets and things that we concentrate. We know composites now, everything from golf shafts to water slides are made out of some sort of composite material. So they've changed a lot of things. So with the modernization of machinery and the speeds that we have now, time and speed are money. Accuracy and rework are not acceptable. Fast, accurate, good parts are what we need to get. And we get these fast, accurate parts through a combination of things. One, Patrick talked about robotics. We don't need to think about robotics as these fancy things that look like your arm that can go everywhere in the world. Those are wonderful devices, but they're expensive. Yeah. There are much simpler things, as he talked to Cartesian robots, and another name for a Cartesian robot is a pick and place. So it just has some sort of end effector, so the vacuum cup or an arm or anything, but it basically moves things from this pile to this machine and back to this pile or to another pile. But they're very, very simple machines. They're very fast and can be relatively inexpensive, and they're simple to maintain. Where a 6-axis robot, if something goes wrong, it's more complicated than a CNC machine, and it's fully CNC operated. So there's a lot of, you have to fit the application, the model for the application.
But
so
go
ahead.
No, I should say one thing that's important about some of this is we have machines now that can do multiple functions. They're fast, they do a good job, they're accurate. But what happens when you crash the machine and you get it out so it's not accurate anymore. The technology that's moving forward to be able to get you that machine back to where it needs to be as quickly as possible and as accurate as it was. That's another thing that's happening in the future. It used to be very, very complicated. You had to get a technician out to manually do everything, but now it's much better. But you're saying something, Patrick.
But to finish Mike's point, not only that, but the controller manufacturers are stepping up. So on the controllers we use, we can actually send a solid model, an STL file of the actual part, and it creates a safe zone around that entire place, so we cannot crash into that part. So everybody's trying to help, but I want you to think about the common theme that we're hearing here. So one more thing, right? We're talking about, less input, more output again. The one less thing. So we're talking about the robotics part of it. That's stage number 3. I'm sure Marty's going to talk about, we're going to check the part while it's still on the machine. And he's going to talk about constraints on the parts. I mean, anybody who's cutting a carbon fiber molded part knows that as soon as you take it off that fixture, it's changed. It's going to move, and you're not going to get an accurate reading. So can we still check it on the machine? Huge, another step that we're talking about there. And the other thing, from a CEO standpoint, you really want to think. You have to think down the road and not what you need right now. Because imagine 6 to 10 years from now, if your machine isn't really ready for a robot, did you choose the right machine, or are you prepared to buy a new machine? So if you're not thinking about the thought process, I'm going to buy this machine right now, and in the future I'm going to put a robot on there. So how does that change my need for this machine, and how does it change the design for it?
Armand, I don't want to disclude you, so why don't you explain a little bit about the system that you are using for your go no go with your to check your head alignment, and also your artifact. You want to talk about that a little bit?
Sure. There's a lot of areas where, much as in our regular everyday lives, technology is continually permeating into our lives, and CNC machinery is no doubt no exception to that. And for us, quite a few ways we're incorporating a lot of different new technologies, capabilities that we're working on today for tomorrow. What you're mentioning here, Marty, the go no go is a system that we've had in place, and it's becoming increasingly advanced with other softwares that are coming out from the controller company that we exclusively work with. Ultimately what's possible is for us to use an artifact on the machine. And if there's a number of ways of going about it, but for instance, if there's an event on the machine, we can enter an M code, and the machine can check itself, essentially verifying whether or not everything is seen as in the same place it was prior to the event. It is getting more and more sophisticated in that there's becoming a kinematic auto calibration being incorporated in the controllers that we work with, in that the machine can not only recognize whether or not something has moved on the machine, but it can actually update the parameters and tell the machine where the different components are, and essentially through the software realign itself or account for the deviations automatically and get back to work. Perhaps it still needs service, but there's a very good chance you could still be within tolerance on your machine.
And one of the beauties of this is you can check this before you start a new part. So
That's another
many
way.
of the parts that go on our machines can cost more than the machine.
Yeah.
So you
Right.
definitely don't want to start a new part before you're able to verify the accuracy of the machine by your artifact or through the recalibration if necessary.
Certainly, and many parts ran in batches. You can, at the beginning of each shift, at the end of each shift, run this, and that way you know what batches were ran and during what shift it was ran. So you would know potentially which batch of parts might be affected and which ones after that. And that kind of goes into technology and how everything is going. It's tracking and data and just really working smarter and having to put less input into increasing your output, and knowing what is what, and increasing your capability by the machine giving you the information that you need to achieve your production goals. A great number of ways. I'm sure you have some more topics to bring up as well, Marty, but a couple I did want to hit on before we get to the end here. But machines and the technology, they're getting smarter, and it's no doubt driven by technology. But adaptive machining, where there's smart sensor packs inside of the spindles, servo feedback, allowing the machines to adapt to the situations they're under, but also report as well and predict when maintenance is going to be needed and or coming up or is imminent. And the machine would be smart enough to shut itself down or at least give you an advanced notice. And that predictivity is really pretty critical for your productivity. And that if you can schedule your downtime, you're in a much better shape than reacting to the machine just being down, having to order parts, and getting that feedback ahead of time allows you the time that you need to put everything in place and really minimize the downtime, minimize the amount of resources you have to put into a situation, and streamline your process. And I think you have a little bit more on those kind of.
I'll get into that in a minute. There's just one other thing I'd like to bring up, and because this is talking about the future of technology, and obviously we're all involved with composites of some sort. And what we're finding out is a lot of the companies or our customers that are making molds and dies, not necessarily our customers, I should rephrase that, tool and die companies that are making steel molds for steel stamping and things like that. Now their customers are coming to them and say, well, we're no longer going to make this part out of aluminum or out of steel. We're going to make this out of composite. And since it's composite, we're going to make it bigger. So now a lot of their existing machinery is not capable of the footprint that it needs to make this new part. So what they're finding is they're having to go from their traditional machines to larger envelope machines, but their dies aren't necessarily out of Inconel and hard steel and things like this for press stamping. They're going to be layup molds. So a lot of the companies that are traditionally tool and die companies are expanding what they're delivering to their customer, and their customer base is expanding. For example, drones. Now we all hear that many companies are going to start delivering packages with drones and things like this. All of this has to have molds. These drones have to be very, very light so they can have that biggest payload that they can. They're not powerful generally because most of them are electric, so they're environmentally friendly. So these have to be built out of composites and lightweight composites. So a lot of carbon fiber and things are using this. So to make that part, you have to make a plug, you got to make a mold, you got to make a fixture to hold it, you have to have a fixture to trim it. In many cases, and you'll also need inspection. With what Patrick mentioned a little bit earlier, carbon parts are generally super thin. So these thin parts, whenever you unconstrain, or constrain means that they are held in place. So we generally have them under vacuum and they're held into place. They'll be trimmed. But if you have to inspect that part to make sure that you're delivering to your customer a correct part, or possibly, especially in aerospace, you may have 100% inspection required. So to make sure that you get the right, you can guarantee the correct part to your customer, you can do on-machine inspections. Traditionally, it's been done with like touch probes, radio touch probes and things like this, but this takes a lot of spindle time and machine time. So some of the things that can be done is faster inspection methods with automated blue light inspection, vision systems, laser line scanners, and these can all be automated using the spindle, or it can be automated on the exterior of the machine with pallet changing systems. So again, you're speeding up, you have less in and more out. So you're not only loading the part, you're inspecting the part, confirming the part, while the machine's working on another part. So this is all part of that same concept, more in or less in, more out, because we're faster and we're being efficient. So the spindle and inspection are done simultaneously. I wanted to speak a little bit about what we're talking about, smarter machines. So early 2000, they came up with what was called MT Connect, Machine Tool Connect. And it was a collaboration. They gave it to the American Manufacturing Association, and it went through Georgia Tech, and Georgia Tech came up with a universally agreed upon language for data collection on machine tools. All the machine tool manufacturers got together and said, okay, we're using this format for all the data collection. So a lot of people have heard of MT Connect. All it is a data acquisition. So the MT Connect of itself can really do nothing. Generally, you have either a third-party software, or if you have the correct people, you can collect that data and place it where you want. But a machine can be as smart as a machine can be only by how smart the person is that programs it. So these supposed smart machines and artificial intelligence machines through the MT Connect using this Industry 4.0, all of this is a good nomenclature. But again, it always takes a smart person to make a smart machine. The beauty of it is it's there. And there are software companies that are streamlining this quite well. And we've got several customers that I've dealt with quite closely on what data to collect. For example, for the predictive maintenance versus preventive maintenance, years ago, you'd say a spindle could do 100,000 tool changes. Then you would have to look into the tool retention method, whether it be a hydraulics or a springs or whatever the case may be. If you use through MT Connect and you gather this data and you find out I have a mean failure of 500,000 tool changes, why change the springs at 100,000 if you can get 500,000? This is the learning. This is the AI of Industry 4.0. But you have to tell it. Tell me when I get a failure on tool changes. And you monitor that, and it will help you learn. So you don't have to look at all the averages of all your machines. So that is what MT Connect and Industry 4.0 are. They're ways to collect data and help predict when you're going to have a failure. Preventive maintenance just changes it every year. I change this every year. What if you can go 2 years? So it's downtime. Again, we're trying to make the machines more efficient, more reliable, and get more production out of them. One other thing I'd like to talk about are machine calibration. So we've made these machines much, much faster, much more accurate. But we have to maintain that. Armand talked about if there was an event or a mishap on the machine, we don't want to produce a bad part. So some of the things that we can do is we can automate the inspection as a go, no go. We can use touch probes. We can use the laser trackers. There's many, many different ways to come up with this. But the calibration of the machine to get the potential out of the machine, there are many different ways to calibrate the machines. All machines are capable, well, I shouldn't say all, but all that we deal with, and any advanced level machine is capable for linear calibrations. So if you ask for 10 inches, you get 10 inches and not 10 inches and 2/1000ths. There's also straightness compensation, where if you have, we don't like this, but say you, for example, you have a twist in the machine, or you have a sag in a bridge or something to this effect, you can tell one of the other axes to compensate for an axis movement. So for example, if you have a sag, you could, as the y-axis move, you say Z has to move up this much for this position in Y. So you can make the machine electronically better. There's other levels, and we're probably going to start running a little bit close, but I want to get into 3D volumetric compensation. This has been a very, very hot word for many, many years. And what 3D compensation is there's 3D compensation and there are 3D rotary compensations. So 3D compensation basically makes a grid of the entire machine at any location. Throughout this envelope, we can tell it to make a correction to make the X, Y, and Z exactly at that point. So that's 3D compensation. It's a very, very useful thing. One thing to realize with any volumetric compensation or 3D compensations, you can make a machine one step better than it was. So you can make an average machine okay. You make an okay machine good. You can make a good machine great, or you can make a great machine phenomenal. And really, when you start getting into the higher level machines, your limiting factor is the ability to measure. Laser trackers still, they have accuracy of about 1/1000th of an inch per 20 feet, maybe. So there are devices they've been around for a while, but they're just now coming into their own, where they're called laser tracers. They do triangulation between multiple setups, and they can position themselves under 10 microns in a volume triple the size of the machine behind us. Now that we can measure this accurately, we can compensate very, very good machines into excellent machines. These are very, very important things. You can only improve what you can measure. So the capability of now measuring at these higher accuracies has become reality. The last part of that is the rotary calibration. So we know there's 6 degrees of freedom in any machine tool. The 6 degrees with the grid, the 3D, gives us our X, Y, and Z position. With the 3D rotaries, they'll give us alpha, beta, and theta. So they will give us pitch, yaw, and roll of the C-axis and the A-axis at any given position on the machine. And the beauty of using angular offsets is because a short tool and a long tool are going to have different positional offsets with a angle on the pitch yaw or roll. So this is the highest level that any machine tool is capable of now. Luckily, all the controls that we're familiar with and we use are all capable of it. We've done it on all of our machines, on many of our machines. It isn't required very often, but if you need the nth degree, this is something it's done to make the top level machine the top of its capabilities. Mike, would you like to talk a little bit more about additive? And Patrick, you talk about additive that you do a little bit?
Let Armand talk about.
Well, additive node is a growing field in our industry. Certainly, perhaps we could still say it's in its infancy very much, but many advances coming along the way. Additive, we focus primarily on the metal additive in-house, and this is really by its nature has to be a hybrid machine in that it both has to be additive and subtractive, and that as you're laying metal down, a bead of metal and whatnot, you have to control the growth and plane as you go. So it really makes it a very functional machine. It could be, in some sense, a welder. It could be an additive growing machine, but it is also, at the end of the day, also a subtractive or a standard routing machine, which is really a pretty attractive thing to the industry as it goes forward, in that it has multiple operations, much like we are seeing and hearing so much more and more often about. I need my machine to do more, multiple operations. A lot of times we can achieve that by having multiple heads, and that it can do the same operation multiple times simultaneously. And even more increasingly lately, we hear about multiple path machines that can effectively run two different programs at the same time. Talking about getting the most out of your machine, it's hard to say you could get any more than that out of a machine if you're cutting two different parts simultaneously. And that's just one of those things that allow us to get more out of your floor space. We get more output out of a single machine, which is always fantastic, of course. And that is just a smarter thing to do. It's faster productivity. And that's really what we fight on day in, day out, is really trying to make our machines smarter, better, safer, and faster for everybody out there. Smarter is really what I was hoping to hint on in the sense that, of course, I focus on innovation, and some of the things that we're here to talk about is the future, and what does that look like? And, so if you really think about what the future looks like and you pull your phone out of your pocket, that was the future really not too long ago, it seems like. And out of our machines, what you'll see is more intuitive HMIs that allow a user to more easily accomplish what it is that they need to on the machine, which reaches back to less input. If it's just an easier machine to use, more intuitive, more modern, you'll get more out of it. Especially lately, people work from home, and it might sound kind of crazy, but it's going to a point where eventually CNC machine tools will have remote interfaces, can be ran almost, practically lights out, and allow people to not even have to be at the machine to operate the machine or have the status of the machine, monitor it. And that comes through the connectivity that you had mentioned there a bit ago, Marty. And then also vision systems, again, less input. Putting a part on a machine, it takes time to get it in the the perfect position to get your part cut perfectly. A vision system can scan a part that's just laid on the machine, and the machine, as we're doing more and more of this lately, adapts to that part as it sits. Less setup, less time put into getting that same single part out of a machine. And it's just another one of those ways that we are seeing our machines increase intelligence through technology. But again, it takes somebody to program that in there and has to ask the questions and find the solutions for the machines to offer that capability.
Yeah, Armand's been working on a pretty fun project to talk about that a little bit more. That basically they have to know the style of what they're cutting on the table is the only thing The only thing that they need to know, but we don't need to know what size it is. So they have essentially, they can put any size on there. It'll measure the part, write its own parametric program, and cut it without any operator interface whatsoever. And not only that, but it's doing force control instead of position control at the same time. So a pretty advanced little machine. It's a pretty successful project that Armin's been working on. So
I know we're getting
A lot of fun
into
stuff.
our question stuff here in a minute, but one thing I'd like to point out, because all this stuff we talk about, the future of machining, the future of the technology, it's all here today. But then you start seeing, at least I start seeing it when I listen to all of this, is, man, how much is that going to cost me? You don't have to start out with all of this. You know, again, you go back to your white paper. What's important today? If you know that you're going to be getting into short runs and you want a UHF system, if you want in the future you're going to add a water jet, you plan for that. You don't have to buy it all today. Get a machine that's capable. And Patrick started out with this. It's capable of robots. So it's predisposed for any or all of these other options that you want to add as you move forward, as you grow, as you see your future getting into other things. So it's not an all or nothing. You can start out with your regular 5-axis, 3-axis machine, do what you do, your bread and butter is making you money, and then just be prepared to grow as you go. And are we getting notices from you to shut up?
okay,
Yeah.
it's time for questions and answers.
All right. Well, thank you guys. That was a great discussion. We appreciate it. Well, like I said, we have a few minutes now for questions for our presenters. So attendees, if you have a question, please use the Q&A field right now on your screen. We will start with a few that have come through already. The first question here has to do with additive manufacturing, which you guys touched on a little bit. So obviously, when you think of composite 3D printing, obviously parts are not coming out of the 3D printer ready to use. They have to be machined afterward. Have you guys worked on projects for hybrid manufacturing, combining additive and subtractive capabilities for composites specifically, or how does that fit into the landscape?
I couldn't understand that completely.
Talk about the project. They asked about projects that you've worked on for additive, and you've got a very good example.
So it's actually both of our companies does some type of an additive hybrid. Yes. So the answer is yes to your question. Armand and I focus mainly on the metal. Don't say the words.
We
Those guys have a polymer solution that does exactly that. And again, there's a focus for that. I think in the future, when you start talking about hybrid and additive machinery, there's not going to be one thing that does everything. So I believe there's going to be niches that are going to start to form on the type of 3D printing that you're going to be doing. So it's a different 3D printer that's going to make the layup molds or the check molds or the trim fixture molds. All those molds are kind of, needs a little bit different machine. And I know that those guys over there have a fantastic way to make trim fixtures, and I thought it was very innovative the way they did it. We were also working on a polymer, and we can do polymer, but we decided to focus on the metal because that's what we were selling into.
Yeah.
But yes, it can deposit the material, it can shape it to hold a fixture, or it can shape the entire outside. We had a customer on one of our machines. They had 900 parts. There's literally 900 parts that they had to make individually and bond together. And they did that in one 3D printing, and they 3D printed this part, and then they basically finished it on the machine. So detail the holes, but it was from 900 parts to one part. I think their lead time was, it was like 4 months for one part. This was a simulator, and they got it down to like 3 weeks when they did this.
And one of the things they add about with additive manufacturing or material depositing, there are many, many, many different types of additive manufacturing. Now 3D printing and all this, you can buy them. I saw a 3D printer at Home Depot.
Yeah.
So there are many, many things you can do with this. It's very important to understand what each one does. Like the one that Patrick and Armand make, it deposits metal. So basically it's a welder, but you can come up with a finished part. So for example, if you're in some remote location, say you're in the oil fields in northern Alberta, you can make parts that break. and replace that part and put it in place. There's other ones that are meant for like we do with polymers. So the polymers can have a million different additives. There's epoxies. Some of the depositing devices can heat up to 600-700 degrees. So you use thermosetting, thermoforming materials. We have an application where they're printing a layup fixture for aircraft parts with a ceramic base of thermosetting resin. And after that fixture is made, they can take and lay up the part, take that part into an autoclave and heat it to over 500 degrees in vacuum, and then bring it to the machine tool and trim it. So there are many, many applications of this. For example, prototyping. Currently, it's not the fastest way to make anything, but it may be the only way to make something, and it is the fastest way for many prototyping things. And you can do additive manufacturing. You can do an entire automotive model. So you have a concept car. You can print a concept car and mill it to thousandths of an inch accuracy. So if you want to see what it looks like, you couldn't tell if it was putty or if it was steel. So there are many, many applications for additive manufacturing. It's very much growing, as you said, but it's a very, very large field.
On our 5-axis metal deposit machine, metal additive machine, one of the things we're pretty proud of is we actually generated the 5-axis head, which would be impossible to machine with the machine itself. So we made a metal part on a metal make machine to go onto the metal machine that made it. So it was pretty fun with that.
Who's on first?
Exactly.
All right, excellent. Thank you for that. So the next question is about your companies themselves. Could you speak to, I guess, the relationship between DMS and CMS and how much sharing there is between your companies?
Go ahead.
The relationship. It's been in the making for a while.
He cooks some mean spaghetti, if that means anything.
Yeah. It has evolved. It's a very, very good relationship. We learn from each other. We have some products that overlap, but we're able to actually reinforce each other in a lot of areas. We've got a lot of learning still, but to sum it up, it's a great relationship. It has been a very positive thing for all of us.
Synergistic.
Synergistic, I like that.
Would be a good word.
Yeah, it's very good. I haven't found anything negative about it at all.
All right, great. Another question here. Given kind of what you guys have talked about with robotic machinery and automation and the cost advantage that can be gained from that, what would you say about, do you expect companies based in the US or Europe might relocate manufacturing facilities closer to home given those advantages? Or do you have anything to add to that sort of conversation?
No, I don't understand the question.
So they ask, would you expect that companies based in the US or Europe might relocate manufacturing facilities that are maybe not in those countries back to their home countries as as a result of robotic machinery and the cost advantages from that?
I'll take a stab at it.
All right. I have something to say if you don't.
Yeah, the United States has always been known for innovation. It doesn't matter where the machines are built. It's integrating everything together is what makes America where they are. We're the ones that have come up with the ideas. Unfortunately, we don't have a lot of CNC manufacturers in the United States, except Patrick. They have a wonderful machine. We happen to be Italian, but it's still the integration of all of this together to make it work. We're still the #1 manufacturer for aerospace, for rocketry. We've exploded in rocketry. In fact, we were using Russian rockets 5 years ago. Now we're using rockets through SpaceX, United Launch Systems, Northrop Grumman. All of them make rockets that are being used every day. So the innovation of the United States has always been the driving force. I don't see any of this technology going overseas because it loses the innovation of the American engineer and the entrepreneurs that we have. So I don't see anything leaving the U.S. In fact, I see it growing very, very quickly.
All right.
Okay.
Great. Sorry. Did you have anything else you wanted to add to that? Didn't want to interrupt you there. But,
Do you say no?
No.
okay. All right. So I
No,
think,
there's an important thing to say about the relationship and the synergy between the two companies is that, it's important. Like I say, I feel like I'm doing a disservice to the customers I talk to if I don't mention what's the future going to look like for you. What are your plans for the future? But between our two companies, from a synergy standpoint, there's not much we don't offer. I mean, the range of products. I mean, there was a time where in my company I wanted to have a plasma cutter and a water jet, and oh my God, they have all those things, thermoformers, all this stuff that's compatible between it. We're kind of, between the two of us, it's a one-stop shop for about anything you want. And when you're looking for future and new innovative stuff, staying with a vendor that can offer everything is a great advantage.
Yeah.
Well put.
yeah, excellent. Okay, well, I think that's all the time we have now. So any questions that were submitted that didn't get a chance to be answered live will be saved and forwarded to our presenters to be addressed later. So thank you again to all of you guys for this presentation. We appreciate it.
Thank you.
Thank you, everybody.
Thank you also to our attendees for joining us today. We appreciate you being here, and we hope you'll join us again for the next Composites World webinar. For more information, please visit compositesworld.com. And have a good day, everybody.
Thank you.